All right, so something quite ambitious here, which is to have one video where you can, if you fully understand this, you can never stuff up a graph of a circular function. So let's give it a go. This is basically the hardest circular function you can have. It's got vertical and horizontal translations. So let's have a look. It says f of x equals 2 times sine of 2 times x minus pi on 3 minus root 3. So this table here is what I'd recommend if you're going to try and solve for um, everything, solve for everything and to sketch it in total. And obviously you can see here we've got nothing on our axes. We're going to have to do everything from scratch. So let's see if we make some sense of it. The first thing is we need to know what the amplitude is. Now, again, by the time you're sketching it, you should know what all of these terms mean: amplitude, period, scale, shape, mean, x and y intercepts. So the amplitude is whatever this number is, right? It's the coefficient of the entire function. So in this case, it's 2. So we can say that the amplitude is 2. Okay, the mean is basically the vertical shift up or down. So that's the mean line. That's the point around which the trigonometric function oscillates. So we're going to say the mean is at negative root 3 in this case, because this is how much it's been shifted down. Okay, the next one, the period. Oh, sorry. What we're going to do is we're going to put that on our graph straight away because we know that that's the mean line. Negative root 3 is a negative number. So you just got to put it below the x-axis somewhere and use dashed lines to represent that line of oscillation, because this is all going to be part of helping us graph it. Okay, we then know that the maximum point is going to be negative root 3 plus 2 because the amplitude is positive, is 2. The amplitude's always positive, but the amplitude is 2. So we need to have our maximum part of our function is going to go up to negative root 3 plus 2. And similarly, the other part of our function is going to go to negative root 3 minus 2, which is down the bottom here. Okay, so they're the first things you want to draw on your graph. And I forgot to mention as well that we're sketching this between 0 and 2 pi. So this is why I've cut off the left-hand side of the page. We're only graphing between 0 and positive 2 pi. Okay, so the period, the way we find the period is 2 pi divided by the coefficient of x. So in this case, the period is going to be pi. So it's going to go through one full cycle in pi radians. Okay, the scale. Now, the scale idea is purely just for your graphing understanding, or to be able to graph it well. So usually when we do the scale, as in how we're going to scale our x-axis, we do it as a quarter of the period. So a quarter of pi would be pi on 4. However, here's an extra tip, and this is why I wanted to do this type of question. You can see that there's been a horizontal translation of pi on 3 units. So even though ordinarily our scale would be pi on 4, we're actually going to want to pick a scale where that's a factor of pi on 4 and pi on 3. And so hopefully that's jumping out to you as being pi on 12. So the next thing you're going to do there is you're going to, on your x-axis, you're going to put in the points pi on 12. So pi on 12, 2 pi on 12, 3 pi on 12, 4 pi, 5 pi on 12, 6 pi on 12, 7 pi, and so on, all the way up to 24 pi on 12, which is 2 pi, because that's our endpoint. Okay, so you've got your scale, you've got your sort of line of oscillation, you've got your maximum and your minimum. The next thing you want to do is you want to think about the shape. So you're just thinking about what graph we've got. We've got a sine graph and it's positive, so it's going to have this general shape. Okay, so that's just going to give us an idea for what it's going to look like when we sketch it. Okay, the next part is tricky. We've got to find the x-intercepts. So the x-intercepts of our graph. Okay, so to find x-intercepts, let y equals 0. So we've got 0 equals 2 times sine of 2 times x minus pi on 3 minus root 3. Okay, you'll notice here I've got a different domain, because remember, when we're solving for x-intercepts, we have to adjust the domain. So what that means is, the way I've got this negative 2 pi on 3 is basically we're adjusting it. We're putting our domain value. So our first domain value is 0. Our left endpoint, you can think about it as 0, but then it's undergone these transformations. It's 2 times 0 minus pi on 3. Well, 0 minus pi on 3 is negative pi on 3. Multiplied by 2 is negative 2 pi on 3. So that's going to be sort of our left point. Okay. It's going to be sort of where we're going to start to think about where solutions could be from. And then we're going to substitute in 2 pi inside the brackets. So it's going to be 2 times 2 pi minus pi on 3. So that's 10 pi on 3. So 2 multiplied by 2 pi minus pi on 3 is 10 pi on 3. Okay, and so what we do then is we solve it, so we get things on the other side. So we're saying add root 3 and divide by 2 gives us that. And then we need to think about where our solutions are. So where is sine equal to positive root 3 on 2? Well, hopefully you recognize that sine's equal to positive root 3 on 2 in the quadrant 1 and quadrant 2, so above the x-axis, because sine is positive. But we need to go between negative 2 pi on 3 and 10 pi on 3. So negative 2 pi on 3 is around here somewhere, because 0 radians is here. Pi on 3, remember, is 60 degrees. So negative 60 degrees, negative 120 degrees is around here somewhere. So this is sort of where we're starting from, and then we're going to go in this direction to catch our solutions. Now, we said that our sine solutions are in these two quadrants. We're going to have one at pi on 3 and then at 2 pi on 3. And then we're going to come around all the way around here will get us to 6 pi on 3, so we can keep going. We'd get to 7 pi on 3, and then we'd get to 8 pi on 3. So remember, we've still got whatever's in the brackets, so if I expand it in, I get 2x minus 2 pi on 3 equals, as we said, pi on 3, 2 pi on 3, all the way around, 7 pi on 3, and then 8 pi on 3. Okay, and then what you need to do is to get x on its own, so you just got to solve that. So you're going to add 2 pi on 3, so you're going to add 2 pi on 3 to everything. So that gives you this, pi, 4 pi on 3, 3 pi, and 10 pi on 3, and then divide everything by 2. So you get pi on 2, 2 pi on 3, 3 pi on 2, and 5 pi on 3. So they are our solutions for the x-intercepts of our graph. So there's 4 of them. Okay, the other thing we need to find is the y-intercepts. So to find a y-intercept, it's a bit easier. Let x equal 0. So 2 times sine of 2 times 0 minus pi on 3 minus root 3. Okay, inside the brackets becomes negative 2 pi on 3. That's where we have to know our exact values. So that's negative root 3 on 2. So 2 times negative root 3 on 2 is negative root 3. All this part here is negative root 3 minus root 3, which is minus 2 root 3. So you've got minus root 3 minus root 3 gives you minus 2 root 3. Okay, and then we can start to think about what we can actually do is we can put that value. We know that that's our left endpoint because that's a y-intercept, and we're starting at x equals 0 for our graph. So we can put that point on the graph, and that's around there somewhere. Okay, now this is the step that I highly recommend. What I want you to do is get a gray lead out, and you need to sketch it as if there was no horizontal translation. Okay, so you can see hopefully that this is a horizontal translation, pi on 3 units to the right. So we're going to sketch it as if that's not there, because we know what the general shape looks like. We know that it's going to start here, it's going to go up, down, it's going to go through 2 cycles. So let me show you what I mean. It's going to look like this if we were to just sketch it roughly without the horizontal translation. Go through, so around there, it's gone through 1 cycle. So that's pi radians. And then to here, it's gone 2 cycles. So that's our graph without the horizontal translation. And so now the horizontal translation, we're basically going to shift that pi on 3 units to the right. So everything's going to get shifted pi on 3 units to the right. So, let's just make sure we're clear about what that means. So this point here is going to get moved pi on 3 to the right. Now remember, our scale is on pi on 12. So pi on 3 with represented as pi on 12 as a denominator is 4 pi on 12. So we're going to move it 4 of these units here to the right. So you'll notice all these points. So this point here, let's say, we'll move 4 to the right. 1, 2, 3, 4. So it's going to be there somewhere. And as we sketch it, let me show you. This is our final product. So let's just take this example here. This point here got moved to here. So it's gone 1, 2, 3, 4 across. Again, similarly here. This point here, this sort of maximum point is gone 1, 2, 3, 4 across. Okay, and then don't forget that you need to continue your graph. You need to continue your graph down to 0. Okay, so That's how we sketch them. And so what we're going to do is we're going to put on these points in here. So we can probably get rid of them. This is why I recommend doing that first line in grey lead, because that's not your final answer. Your final answer is obviously the orange line in this case. And then we know all of our x-intercepts are over here. So we can put those on. So pi on 2, 0, 2 pi on 3, 0, 3 pi on 2, 0, and 5 pi on 3, 0. And the very last thing you want to put on is your endpoint. You know, this one's at 0, negative 2 pi on 3. You know that we've done a period, we've done 2 full cycles. The period is pi. So, you know, from here to here is pi. And then here to here is also going to be pi. So we know that this must be at 2 pi, and it's going to be at the same y value, negative 2 pi on 3. So that was a bit of a marathon. That's how I would highly recommend you graph all of your trigonometric functions, because you're very unlikely to make errors if you follow all of those steps very carefully. I haven't labeled the maximums and the minimums on here, but I'm sure you could work that out. You know, it's symmetric. So you know that the maximum point here is obviously at negative root 3 plus 2 as the y value, and the x value is, well, you know your scale. So pi on 12, 2 pi on 12, 3 pi on 12, 4 pi on 12, 5 pi on 12, 6 pi on 12, 7 pi on 12. So this pointer here is 7 pi on 12, negative root 3 plus 2. And you could do similar things with all the other points. So that was a bit ambitious. Hopefully that made a bit of sense. Try and follow that process for graphing any sine and cosine graphs, and even tan. You can follow a very similar process as well. Hopefully that makes a bit of sense.